retired senior professor after serving about 40 years in Electronics and Communication Engineering Department, College of Engineering, Anna University, Chennai. He is presently working as Principal, Pratyusha Institute of Technology and Management, Tiruvallur, Chennai. He has 40 years of teaching experience in the field of electronics and communication engineering. He had visited countries such as USA, UK, Germany and Sri Lanka on various academic activities. He has about 90 research papers to his credit. He has guided 6 PhD scholars and 3 MS program scholars. He has published 10 books and 10 monographs. He has attended 19 short-term courses. He submitted 33 proposals to the Development of Electronics Department. He had purchased equipments to the tune of Rs 150 lakhs for the growth of the department. He has developed many laboratories such as Microwave Lab, Fiber Optical Communication Lab, Laser Communication Lab, Satellite Communication Lab, VHF-UHF Communication Lab, and UG Basic Laboratory. He conducted more than 50 short-term courses, winter schools, summer schools, and faculty development programs. He executed a number of government-funded projects at Anna University. He received Best Project Awards twice for UG projects at state level through Directorate of Technical Education and at national level President of India Award for the project on telephone for physically handicapped persons. He is a member of many professional bodies such as Institution of Electrical and Electronics Engineering, Fellow of Institute of Electronics and Telecommunication Engineering, and Broadcast Engineers Society of India. He is also a life member of Institution Engineering, life member of Indian Society of Technical Education, and life member of Optical Society of India. His current fields of interest are electromagnetic theory, antennas, satellite communication, and fiber optical communication.
Welcome to UGC lecture series in Applied Electronics. The series covers semester 5 paper 10 antenna and wave propagation, and we are going to see the second lecture. Now we have seen last time some of the basic but very important definitions. Number 1, what is an antenna? Antenna is a radiator. Antenna made up of what? Antenna made up of conductor. And what is a very crucial outstanding thing to be remembered? Antenna radiates electromagnetic wave. And what is the significance of electromagnetic wave? That is a super wave. We can call electromagnetic wave as a super wave capable of moving from one point to another point with a super velocity of 300,000 kilometers per second. With that speed, a wave can cover the total world in just 0 time. For all purpose, please, from at least now onwards, you should be bold enough and confident enough to tell the electromagnetic wave covers the total world in approximately 0 time. So, question of transit is ruled out. That is why we are today looking for what is otherwise called wireless communication. Wireless communication becoming dominating because without wire the total world is touched by the electromagnetic energy in just 0 time. So, that is the beauty of the electromagnetic wave, and that is given by antenna, which is very simple conductor. A very simple conductor is giving super wave. These 2 points you should always remember throughout our discussion. A very simple conductor, but it is giving a super magical wave. Okay, now let us go further. This time we are going to see number of antennas. When you see number of antennas, you should get an idea, a very important point. Now that I want to show you now. We will see first a simple basic fundamental antenna called a Marconi antenna. There are 2 great people, one we have to remember. One is Hertz, other is Marconi. If at all we owe our gratitude If at all we are to thank the two great persons, Marconi and other is a Hertz. That's why the antennas are called Hertzian antenna and Marconi antenna. This is Hertzian antenna. A one which is horizontal, it is always called Hertzian antenna of length lambda by 2. So, whenever you see a horizontal antenna, you should recognize it is a Hertzian antenna. Your TV antenna is a Hertzian antenna. Whereas the Marconi antenna, as you see in the diagram, it is a vertical antenna on the ground of height lambda by 4. A vertical antenna on the ground, it is a Marconi antenna. And your local broadcast, all India radio local broadcast, it is using a vertical antenna of height lambda by 4 approximately. That detail we will see as you progress. So, one must remember this one particular antenna called, what it is called? It is called Marconi antenna. What is the height? Lambda by 4. What is lambda? Operating wavelength. So, it is the operating wavelength that is going to decide what is the height or what is the length of the antenna, and the other antenna is Hertzian antenna. It is horizontal of length lambda by 2. So, there are two antennas. Please remember there are only two antennas on earth. So simple. The topic is so simple. Once you want to go into design or some complication is invited. But as it is, there are only two members of a family, antenna family. When you say antenna family, one member is just like a father and mother, one member is Marconi antenna, other member is Hertzian antenna. Hertzian antenna horizontal, Marconi antenna vertical. If you take any application in antenna field, whatever the complication of antenna, ultimately the origin is only these two. Either they will fall under the Hertzian antenna or they fall under the Marconi antenna. Now, so hat off to the two great people. Now comes a very interesting, another very fundamental concept. Obvious question you should ask, what is the physical length of the antenna? The two antennas what we have seen, the two antennas are of length, one is lambda by 4, other is lambda by 2. What is that lambda? Natural question. We don't know what is lambda. We know 10 meters, 5 meters, 15 meters like a length. Lambda is a new language for us. So, the natural question is what is lambda, how the physical length will be established. That is done by this formula. You can see C equal to F lambda, and the C is nothing but velocity of light. C is the velocity of light and C equal to F lambda. This formula to be remembered. So, we know the basic velocity of light. What is velocity of light? It is 3 into 10 power 8 meters per second or 3 into 10 power 10 centimeters per second. This is a third type of formula where C equal to F lambda, where C is 300. This is a very comfortable formula. C is 300 and F the frequency expressed in megahertz, lambda expressed in meters. So, the lambda in meters, frequency in megahertz equal to 300. Please for your rest of your life, you should remember this formula. From this you can find out what is the length of an antenna. What is the length of an antenna given what frequency you want to operate? What is the length of the antenna if you know what is the operating frequency? Just see two example, it is shown here. One example, suppose operating frequency is 3 kilohertz. If operating frequency is 3 kilohertz, what is the length of the antenna? For that, first I will find out the lambda. What is the lambda? First we are finding what is lambda. What is lambda? 300 by F. What is F? 3 kilohertz. Now this 3 kilohertz I should express in terms of megahertz. So, F in megahertz equal to 3 by 1000, thereby the lambda become 100 meters. This is one extreme case. If I consider operating frequency 3 kilohertz, my lambda, the operating wavelength is 100 kilometer. On the other hand, if I say frequency is 30 gigahertz, 30 gigahertz, other extreme, deep into microwave. If the 30 megahertz operating frequency, my lambda become by the same formula, it become 1 centimeter. Please understand, when you sweep the frequency from 3 kilohertz to 30 megahertz, the lambda changing from 100 kilometer to 1 centimeter. So, the lambda is not constant, lambda is a direct function of wavelength, that you have to understand. And what is the length of the antenna we are going to consider? Lambda by 2. All the antennas here are lambda by 2 in length. What is lambda? You ask what is the frequency. Knowing frequency, I can always find out lambda. Knowing lambda, I can always find out the length of the antenna, which is nothing but lambda by 2. I hope the very basic formula is clear. If I know the frequency, I can guess what is the height of the antenna, what is the length of the antenna. How? Knowing the frequency, find the wavelength. Knowing the wavelength, take lambda by 2, and that is the length of the antenna. What is the significance of lambda by 2? That we will discuss a little later. So, from now onwards, we are very clear by looking into the antenna. Suppose if I see an antenna, I am seeing an antenna. What is the operating frequency? Question is, what is the operating frequency? Simple. This is lambda by 2. This is lambda by 2. Then I know what is lambda, multiplied by 2. From lambda, I can find out the frequency because C equal to F lambda. If I happen to see an antenna of a bigger length, once I see it, I know what is the length. What is the length? Lambda by 2. Once I know lambda, I can find out the frequency from C equal to F lambda. Like that, I can find out any operating frequency of an antenna by looking into the structure. If I see an antenna, I roughly guess what is the length. Once I know the length, it is lambda by 2, multiply by 2 lambda. Once I know lambda, I can find out the. So, from today onwards, when you go around the city anywhere, if you happen to see an antenna, simple look of the antenna will give an idea what should be its operating frequency. Conversely, if you want to operate a signal at a particular frequency, you fix a frequency, then you find out what is lambda. Once I know the lambda, what is half the lambda, that is the length of the antenna. So, now you know the trick how to decide the length of an antenna, how design an antenna. Design of the antenna is over. The whole subject based on a very simple formula how to design an antenna. Okay. So, antenna from now onwards should give you an idea what is the operating frequency. Here is another very important concept. By now you should have got a doubt how antenna radiates. It is something funny. It is something very funny. I am seeing a rod. I am telling it is radiating. It is like a magic. How it can radiate? It is a rod. And I am giving signal to this rod and I am telling it is radiating. Suddenly how it radiates? It is a very common sense question. So, that is a simple beauty. That depends upon property of the particular material and the dimension of the material. For that we are now seeing a very important concept. It is a concept. What the concept? You are seeing a sine wave. This is a sine wave. And what is the length of the sine wave? It is comparable to lambda. Our lambda scale is a very crucial now. Lambda going to play a very important role. So far we are familiar with a meter length. If I say what is the length? It is about 1 foot. What is the length? It is about some 5 to 6 centimeters. So, what is our unit of length? Centimeter, meter, like that. From now onwards, at least from today onwards, our yardstick is lambda. It is not meter, it is not kilometer, it is not mile. My reference yardstick is what? Lambda. If I measure, how I am going to measure? This is 1 lambda, this is half a lambda, it is 2 lambda, it is 10 lambda. So, my RC now becomes lambda. As a communication person, from now onwards, you should measure any length, height, width, thickness, any length you should able to measure in terms of lambda, provided if you know the operating frequency. But what is the beauty? The beauty is, what is lambda? That is the question. I can measure everything by lambda, but what is lambda itself? To find out that lambda only we gave a formula, C equal to F lambda. So, the moment I know the frequency, I can always find out the lambda. Once I know the lambda, then I can always measure. But here only we are making a caution. My lambda is changing. My lambda is changing. When my operating frequency is 3 kilohertz, my lambda is 100 kilometer. Please cautioning, I am cautioning. It is 100 kilometer. That means I am taking a scale. What is the length of the scale? 100 kilometer. So, if I measure something, 1 means what is the length I am measuring? 100 kilometer. Same way, if I go to the other extreme frequency 30 gigahertz, what is my lambda? 1 centimeter. So, my lambda become 1 centimeter. So, what is this length? This may be 10 lambda. This may be 10 lambda. This may be 20 lambda, because my lambda is 1 centimeter. Please understand the point. The dimension is not changing, dimension is same, but what is the scale I am using? Whether I am using lambda is 1 centimeter or lambda using 100 kilometer. If I measure the same length by 100 kilometers lambda, this is practically 0 lambda. If I use a scale of 100 kilometer length, if I measure with that, what is the length of this? 0, because for 100 kilometer it is nothing. Whereas, if I measure the same thing with the lambda equal to 1 centimeter, this becomes 50 lambda, 20 lambda. So, this is the fundamental beauty you should remember. Physical length remains same, the physical length remains same. Once I change the operating frequency, if I use this antenna at 3 kilohertz, what is the length of the antenna? 0 lambda. If we use the same antenna at 30 gigahertz, the length of the antenna become 15 lambda. So, that is the magic, that is a simple magic. Simply changing the frequency, the length is changed, that is called electrical length. The changing length is called electrical length. So, one has to be very conscious about that. What is electrical length? What is physical length? What is the difference between them? We will continue after a small break. Welcome back to the continuous series now. We left at the discussion of wavelength, lambda. Lambda is a wavelength, operating wavelength, and operating wavelength is not an independent quantity, it is related to frequency. Well, as a communication people, most of you are aware that we are using different frequencies. The natural question you should ask, where is the need of different frequencies? Yes, we are using different frequency. The frequency we are using for Doordarshan is different. The frequency we are using for all India radio is different. The frequency we are using for data is different. Like that, every application, the wireless communication, communication between airport, the communication between ship, the communication between the trains, the communication between aircrafts, the communication between the human being, they are all different frequency operated signals. So, one has to be clear that we are using countless frequencies for countless applications. So, there is a need of using variety of frequencies. That is why the electromagnetic spectrum runs from few kilohertz to few hundreds of gigahertz 10 power 9. So, it is a very wide spectrum that most of you should have studied under communication topic, what is called frequency division multiplexing. So, we are very clear that there is a need of variety of frequency utilized for signal transfer. When you are using different frequency, we are using different antennas. For all India radio, I am using one antenna. For Doordarshan, I am using another antenna. When I say another antenna, size is different. I will be using for television a short antenna. I will be using for a all India radio a bigger antenna. I will be using for a satellite a different antenna. So, different application, different frequency, different antennas, different dimensions. Antennas are differing in dimension. What is the dimension? That is lambda by 2. What is lambda? That corresponds to the frequency of operation. I hope the basic concept is clear. We should aware of what is my operating wavelength. Once I know the operating wavelength, I decide what is my length of the antenna. So, there when you just go around the city, you can see variety of antenna. Now, we were talking about radiation. Radiation is a very, very, very powerful concept. Very powerful concept. Antenna radiates. How it can radiate? A conductor, how it radiates? Yes, it is capable of radiating provided if the length is comparable to one wavelength. Ruling given. What is the rule? If the length of the antenna is comparable to one wavelength or comparable to wavelength, it gets a property of radiating. It is no longer keeping energy inside. When the length is small, it cannot radiate. When the length is comparable to lambda, it radiates. A sudden property. It is not that only this rod radiates, this rod not radiates. It is not that way. The moment length is comparable to lambda, the rod which is not radiating, now it radiates. Why? The length is comparable to lambda. It is a very powerful concept. All your microwave working on this principle, all antennas working on this principle. So, the ruling we are telling, which you should not forget, whenever a conductor length is comparable to operating wavelength, it gets a new property of radiating energy. You would have done in circuit. When current flows in a wire, the energy dissipates. When a current flows in a wire, it dissipates the energy in the form of heat. But the moment the length becomes comparable to wavelength, it radiates. So, antenna is a radiator when the length becomes comparable to lambda. So, this ruling please remember, circuit is not radiating. What you are operating circuit in the lubber, it is not radiating. Why? The dimension is not at all comparable to lambda. So, it will not radiate. Antenna radiates. Why? Antenna length is comparable to lambda. So, here onwards, any conducting system, you can call as an antenna, you need not call as an antenna. If the moment it is a conductor and if the length is comparable to lambda, whether you want or you don't want, it radiates. If you want, it is a useful energy. If you don't want, it is a radiation loss. We call as a radiation loss. If you want, then you call as an antenna, it is useful and powerful communication. So, thereby the lambda scale is a very powerful scale, and when lambda become comparable radiation, when lambda is very big, then it is not radiating. Now, that comes your very interesting very basic antenna. In fact, this is only called a transmission line where energy is taken to the antenna. This is antenna. Please look into the diagram little sharply. This is also conductor, this is also conductor, but we are telling this is radiating, but this is not radiating. What is funny thing? Same wire, up to this point we say it is not radiating, but once you come to this extreme end, it is radiating. What is the difference? Here the difference is, these two rods are in line, whereas these two are parallel. If you look into the current flow, if suppose the current enters here and goes out, and afterwards it comes around and again enters back and come in. Please follow, the current enters, it goes in and goes out like this, and maybe it is completing the circuit by free space and again getting in the wire and coming back. Please follow. I am going to ask you the question. It is getting in and getting out. If you see the current in these two arms, they are opposite, yes or no? Current entering, going around, coming back. So, from this part alone, if you look at, current enters, current leaves, that means the current is in the opposite. Now, you follow here, current comes out, close the loop, come back and current enters. Now, can you see the difference? Current going up, coming around, again current going up. So, in these two arms, current are in the same direction. So, even though all are conductors, in the horizontal wire, the current are moving in the opposite direction, whereas in the vertical portion of it, the current in the same direction. And thereby we are telling there is no radiation here, but there is a radiation here. So, only this portion acting as an antenna. That means what is the conclusion? The conclusion is, in the antenna system, the current in that system should be in the same direction, it should not be opposite. So, though they are all forming the same system, though all are conductors, this portion, I am not telling this is not a conductor, this is also a conductor, but this portion not radiating, but this portion radiates. So, then what is the job of this portion? This portion giving energy from the control room. From the control room, energy comes, it flows through the wire and it is radiated by the antenna. So, this is called transmission line. You are using telegraph wire as a transmission line. You are using telephone wire as a transmission line. You are using wires running between television set to the antenna. That cable also called transmission line. So, when you use the word transmission line, it is not radiating. When you say antenna, it radiates. But there is a connection required, because to the antenna energy has to go, so it radiates. Similarly, energy will come from space to the antenna, and from the antenna collects energy and send it back to the control room. Fine. Now, we are going to run through few slides, very interesting. Now, you will appreciate, probably I will post few questions at the end. We are going to see variety of antennas, simple variety of antennas, and you have to identify where is the real difference comes. Now, you can see a mast is a very common antenna you see around the city. It is a mast running about some tens to hundreds of meters, very, very tall mast, and this mast has to be vertical, very important. The antenna should be vertical, because we are going to call this as a vertically polarized antenna. So, it has to be vertical. To be vertical, in the middle of heavy wind and other things, it should be supported by, you can see, I hope you can see the wires, these are all called guy wires. You can see thin wires running around the antenna. Around the antenna, all these wires are holding the antenna vertical. So, that is why it is called guide mast. Guide mast, the whole mast is radiating. An antenna running about hundreds of meters, the whole mast is radiating. So, what is the lambda in this case? It will be lambda is very high. Lambda is about 20, almost 100 meters what you are seeing it. Naturally, the frequency is going to be on the lower end, that you should guess. Now, you can see there is a whole structure again radiating about 20 meters height. It is a three-sided structure, very strong structure, about 20 meters height, and the whole structure is radiating and it is fed at the bottom. So, this is also called antenna. Naturally, the frequency on the lower end, because lambda is quite huge. You see another tower, it is a tower and the whole tower radiates. Sometime antenna will be kept on the top of the tower also, and again these towers are about hundreds of meters. In Chennai we can see a very high tower, and over the tower Now we have radiating antennas. This is another, you can see this is on the top of the house. Over the roof a tower is erected and it is radiating. Again a tall mast, you see, you can see this is a mast running about few hundreds of meters and this is supported by guy wires. Again another small mast with a plastic rope, and again here a very strong metallic rope, and that is radiating. What I want you to observe, sometimes the mast radiate, sometimes mast support the ropes which are radiating. Some place the mast itself acting as antenna, some place the mast supporting the ropes and the ropes are radiating. You see again mast, these masts are supporting one, in between the ropes are run and the signal is fed at the center and this is radiating. This may be running about some 5 to 10 meters. Again a group of various type of high frequency antennas. Now what are the antennas you have seen so far? They are all falling under the low frequency. See the 3 antennas what you have seen, these are all falling under the low frequency. You can see on the top written it is a low frequency antenna. When I say low frequency, what is the frequency? 3 to 30 kilohertz, low frequency, or sometime medium frequency. Similarly, if you see even earlier antenna, this is again a low frequency antenna. Similar earlier frequency, low frequency antennas. Whereas when you come to this side, this is a medium frequency antennas. Then again this again a high frequency, high means 3 to 30 megahertz. See, I am telling you, antenna subject is always followed by the consciousness of frequency. Frequency very important, because frequency decides lambda, lambda decides the length of the antenna. So when you go to high frequency in the range of tens of megahertz, then your lambda becoming smaller, antenna becoming smaller. We should recognize why antenna structure becoming smaller and smaller, what makes it to be smaller, that we should justify. So we have plenty of, I want to show some different type of antenna at different frequencies. So today we have seen that for electromagnetic energy to get generated and radiated, conductor is a mandatory. We have seen very important concept that antenna as a conductor radiates, something wonderful, it radiates, some magic. And why it radiates, we are giving a thumb rule. As long as the dimension of the antenna becoming comparable, it is capable of radiating. And length of the antenna we are always able to find out from the operating wavelength. So we are slowly building up the very fundamental concept of antenna. Now you should know, at least from now onwards, why an antenna radiates. Why an antenna radiates structurally? Number 2, what is the length of the antenna, how you are going to evaluate? Why certain frequency operating antennas are smaller, why certain frequency antennas are larger and bigger? So these questions you should be able to answer. Then we will be able to understand and appreciate why the antenna structure going smaller and smaller when you go to microwave. That we will continue. Thank you.